Hello, this is the AQA A-Level Chemistry bonding topic, and we've come to the end of the bonding topic now. In this video, we are going to summarise the key properties and the reasons for the properties for the different bonding types: ionic, molecular covalent, giant covalent, and metallic structures. So I'm going to recommend that you pause when questions come up, try them, and then review your answers. Okay, let's get straight on. Three types of strong bond. How are they formed? Well, I've already put the first one in. A covalent bond is a shared pair of electrons. Remember that within there is a subset called coordinate or dative covalent bonds. They work in exactly the same way. They are a shared pair of electrons, but both of the electrons come from the same atom. So let's have a think about the other two questions. So an ionic bond is the electrostatic force of attraction between oppositely charged ions, whereas a metallic bond is an electrostatic force of attraction between positive ions and delocalized electrons. Now for this section, I'm going to recommend you sketch out a table for each of the four bonding types and see what you can do to fill it in. So for ionic, giant covalent, molecular covalent, and metallic, can you remember whether or not they conduct electricity and why that is the case? Okay, so if you've had a go or you've thought these through, we're not going to go through in order. We're going to take a look at metallic. And metals do conduct electricity. And I've gone for this one because it's probably the first one that you ever really learnt about. So why does it do that? Well, it has delocalized electrons and they can carry charge through the structure. Now, the delocalized electrons is highlighted because it's very specific to metallic structures. And I'll talk more about that as we go through. Let's go to ionic next. Do they conduct electricity? Yes, they do. But there are some limitations here. They will only conduct when they are aqueous or molten. And why is that the case? In this, it's not that there are delocalized electrons. There aren't. There are ions that, when aqueous or molten, are free to move. And that means that they can carry charge through the substance. If we go next to molecular covalent, well, molecular covalent do not conduct electricity, and that's because there are no delocalized electrons, or indeed ions, free to move through, but I tend to talk about it in the context of delocalized electrons. And finally, giant covalent, do they conduct electricity? No. And again, same reason. There are no delocalized electrons. However, you've got an additional fact to remember here, and that's that graphite does conduct electricity because there are delocalized electrons that can carry charge through the structure. So explaining whether graphite conducts electricity or not is done in exactly the same way as our answer to metals. I'm going to do a similar thing here now with melting and boiling point summaries. So here's a table. How confidently can we fill this in? Well, we're going to start by putting the highs or the lows. We can see that ionic, metallic, giant covalent are all high melting points, whereas molecular covalent is low. There are numerous difficulties that can be had when you are explaining why they're high or low, and it all comes down to using the correct terminology. So I'm going to try and highlight some of the similarities, and then we can see the differences. So if I take ionic, metallic, and giant covalent, they all start with there are lots of strong something. But here we start to get some variation. In giant covalent, there are lots of strong covalent bonds. There aren't covalent bonds in metallic or ionic. The minute you put those in, you are producing a chemical error. But there is something common with ionic and metallic. They have lots of strong electrostatic forces. So we can talk about both of those in a similar way. But then we start to branch off again with different components to the answer. Ionic have lots of strong electrostatic forces between oppositely charged ions. Whereas in a metal, there are lots of strong electrostatic forces between the positive ions and delocalized electrons. If you talk about oppositely charged ions in metallic, you lose marks. If you talk about delocalized electrons in ionic, you lose marks. Now all of these can be finished off with a simple sentence, therefore lots of energy is needed to overcome them. So we have molecular covalent that really stands out on its own. It's low because there are weak intermolecular forces, and therefore not much energy is needed to overcome them. That takes us to the end of this video and the end of the bonding topic. Thank you for listening. Goodbye.